Good morning, folks. Thanks. Appreciate your time and joining us this morning. Happy to make this as interactive as we as you like as we go through this session. If you can go and post questions, we'll try and answer them as promptly as we can. As Amit said, my name's Gerry Sillars. I'm Vice President of Sales for Asia Pacific for Fortanix. I'm based in Singapore, but as I'm sure you can all tell, I am an Australian. Moved to Australia in 2002. Actually lived not too far from the picture in the background there, and my son lives in the city now. So Australia's near and dear to my heart. I am an Australian citizen, as I said, and probably, equally as horrified, mystified, and equal measures as everyone else on the call with what's happened over the last 6 months in particular with data breaches in Australia. So we're here today to, I guess, educate hopefully you on this call a little bit on how we can help at Fortanix mitigate some of those risks. With me on the call is Nils Westman. As Amit said, I'll just let Nils do a quick introduction as well.
Yeah, hi everyone. So I work as a sales engineer for Fortanix, covering Australia and New Zealand.
Short and sweet. Nils has been around crypto technologies for the best part of 20 years, predominantly in Australia, but has experience across Asia as well. So let's go on with it, Nils.
Okay.
Housekeeping, Amit. So we will send additional handouts post this call to everyone that attended. First and foremost, you can enter your questions on the questions menu that you should see on your go-to webinar app, and you'll also receive the link to the webinar recording post this session. Next slide, please, Nils. So today we want to quickly touch on the changing nature of IT infrastructure, threats and data security challenges, the complexity of navigating between regional and privacy regulations, what are some of the critical data encryption controls required to meet these compliance mandates, how we at Fortanix can help you wade through this complex world of compliance, and we're going to wrap up with the need for external key management and some offers to help you get going to mitigate some of this risk. Next slide, please, Nils. If you can just move on to the next slide. Just again, I mean, this slide is a Fortanix slide, obviously, but one that I'm sure everyone on this call is aware of. For those of you who today live in a combined world of legacy and cloud, this will be familiar. Obviously, over the last 10 years or so, most of us have been working on a digital transformation or a cloud transformation journey, which has proved challenging. Certainly in the security space, it's proved challenging because we've come from a very much a bricks and mortars environment where we had very regimented and rigorous process and controls in place, and people who'd been in roles typically for a long time helping us go and manage our enterprise IT, and that typically sat in enterprise data centers. Over the last number of years, we have seen a move and a rapid move to cloud. As you can tell by the amount of grey hair or no hair that I have, I've been in this industry for quite some time. So that cloud movement over the last 10 years initially was predominantly test and dev, I would say, although my friends at Amazon, Google and Azure or Microsoft may disagree. But COVID really has accelerated, two things, I guess. COVID really accelerated the move from on-prem to cloud with mission critical applications, hosting PII information. And also we've seen an explosion over the last 10 years of born in the cloud organizations. Now, this has brought a whole bunch of challenges. It's brought a whole bunch of challenges, predominantly because in many instances there's been a rush to go to cloud. Many boards have decided that they're going to be cloud first, and there's been probably too much haste to go and move to cloud without properly thinking through the ramifications. Next slide, please, Nils. And this has brought a raft more security threats from both malicious insiders and external agents, because again, in a legacy environment, in a legacy enterprise environment, we have people who have been working in environments for years, well established, well known, well understood. They understand what the edge looks like, they understand what the perimeter looks like, they understand what mitigating controls they've got to go and access the key assets of an organization, which are data. But this move to the cloud has seen a significant increase in threats and in breaches across all forms of cloud providers, whether those are CSPs or other SaaS-based solutions. And we also see a threat across the globe coming from the requirement for CSPs to go and, based on the Patriot Act, predominantly to go and respond to court orders when they're given. So, whether it's Amazon in this case, whether it's Amazon, whether it's Google, whether it's Microsoft, they are required to go and give up your information. So whether they like it or not, they're giving up your information. So that's a threat in its own right, and that's certainly seen the drive across many markets that we operate in to go and look at sovereign cloud environments to ensure that you not only retain your data, but you own and retain the keys to your kingdom within a sovereign boundary of or a sovereign geographical boundary. Next slide, please, Nils. What we've also seen and continue to see over the last number of years is an overwhelming volume, tsunami almost of data privacy regulations around the globe. Now, we've and Australia probably lagging and laggards to an extent. Obviously, we tried a year or so back, maybe 18 months ago, to go and enact a more robust Privacy Act that we spent a bunch of time debating. Obviously, we've gone on to an extent rushed through the latest iteration of that on the back of what's happened over the last 3 to 4 months with the breaches in Australia. But this phenomenon is something we're seeing worldwide. It's becoming very fractional in the US, with different states now legislating their own privacy or having their own privacy legislations. Lots of us in Australia do business in Europe, so if we're doing business in Europe, we're governed by GDPR requirements. I think I saw just the other day that GDPR fines for last year came close to 3 billion euros, with the European Union handing down fines for breaches of PII information. And interestingly, starting to see the authorities in Europe starting to look at AI information and misappropriation of PII data in AI environments, which was a first for me. But all across the region, we see enhanced privacy, which means that us as custodians of the data of our customers, of our staff, and of our citizens have an increased requirement to ensure that we are protecting the privacy of the individual, the citizen, more effectively than we perhaps have done historically. Just go to the next slide, Niels. Now, from an Australian perspective, again, assuming everyone on the call is Australian, because no one in Asia would be stupid enough to get up at this time in the morning to do this call. Otherwise, we've seen the government's reaction to the latest breaches, increasing the maximum penalty for serious repeated interference from a couple of $1 million, which really wasn't a deterrent, to $50 million. You could go and argue that that's a deterrent or not right now. Across Asia, we see a whole bunch of more prescriptive fines in place than that, and potentially for the custodians of that data, some really severe penalties, including jail terms of up to 5 years in some countries. So, I think from an Australian perspective, we still get off light. Again, that being said, the Office of the Australian Information Commissioner has now said that, or is now saying that Australian privacy laws now apply to organisations, to any organisation doing business in Australia, whether or not personal information is collected in Australia. So again, as custodians of data and owning PII data, we have responsibility to go and ensure that we are not misappropriating that data that we are collecting whether ourselves or from third parties. You just got the next slide, Niels. And we know, again, high profile cases, high profile instances. Would a $50 million fine make a difference to the level of the level of investment that these organisations make in trying to protect against those breaches that they had? Probably not. Could they have done anything about it? Yeah, I'm sure they could have. But the reality is, a $2 million fine, a $50 million fine, is to say it's the tip of the iceberg is putting it mildly. The reputational damage, first and foremost, for these organisations is, I think it's going to take us a few years to go and quantify exactly what the reputational damage for both of the first two on this list is. I read yesterday that Optus are already counting lost revenue of up to $1.3 billion already. And again, as we know, well publicised, Medibank could be up for up to $5 billion in Australian and class actions. The horrific thing across just those two is that 56% of our data as Australians, our PII data, has been misappropriated, is out there in the wild, and again, as we know, has meant for Australian citizens, and I'm sure many on this call have been affected, that we've had to go and get new passports, new driving licenses, new Medicare cards, etc. Medibank, obviously, even more horrific in terms of some of the information and data that has got out there. I've spoken to 2 or 3 healthcare organisations in Australia just this week whose CISOs have told me they struggle to sleep at night just with the perceived threat that they see, or the perceived weakness they see in their controls to go and mitigate against these types of things. So, go on to the next slide, please. So, how do you go and keep control of that data? How do you go and watch out for the bad guys? One of the things that we're all struggling with today is that we have a massive skill shortage in IT security roles around the globe, about 3.5 million humans. I think the Australian government starting to react now and making it easier for people with the right types of skill sets to be recruited from overseas into Australia. We certainly see a bunch of work from the government to go and try and help with the education of folk to get into the cybersecurity space. The obvious thing, and when you go and have a look at the organisations on the last slide that had been breached, these are not small organisations. These are organisations that have experienced security staff in their organisations. We believe, if you go to the next slide, Niels, but we believe, as do the Office of the Australian Information Commissioner, that one of the most effective ways to go and mitigate some of these risks is to start focusing on the data. As an industry for years and years and years, we've spent a lot of time focusing on the perimeter. The perimeter in terms of going and spend hundreds of millions of dollars or tens of millions of dollars on firewalls, IPSs, etc., to stop people getting into the network. The edge became the new perimeter, so edge devices have spent hundreds of millions of dollars going and protecting the edge. We spend and have spent tens or hundreds of millions of dollars going and protecting identity. And the reality is all of these things are fundamentally flawed, because the people that are after your data are after the data assets. They're in your network. Typically, they're in whether you're on-prem or in the cloud. These actors are in your network today, or have methods and ways to get into your network. So the OIC suggests that a way you can go and mitigate this and help increase the level of protection as it pertains to data, first and foremost, is pseudonymization or masking or tokenization. So storing processed data, fundamentally storing processed data in a way that it can't be used to identify an individual. If you're on this call and you're subject to PCI DSS requirements, a really effective way to go and ensure that you have no issue from a PCI audit perspective is go and make sure you anonymize all that information. So you're only ever storing information that is anonymized or masked on an individual. The second way that OIC suggests that you go and mitigate this risk is to go and encrypt your data. So go and protect your data with state-of-the-art encryption techniques. Many of us may be doing that today. most application vendors, most database vendors have a way to go and encrypt data today. Unfortunately, they all typically have their own way of going and doing that. But the third way that the OIC say that you go and lock down this environment is take control of your keys. So go and maintain control of the keys that are encrypting or tokenizing that information. And at Fortanix, we really believe that is the key. If you control the keys to your kingdom, then you have control over your data. If your data is tokenized, masked, anonymized, encrypted, and you've got an effective key management strategy in place, then you're much more secure than you are otherwise. On the next slide, Nils. So what are some of those critical data controls as defined? So, first and foremost from OIC, go and encrypt sensitive data using state-of-the-art cryptography. Again, this might sound very simplistic, but in almost every instance where we go and see data that's out in the wild, that's been taken subject to a ransom attack or a hack, that is data that is in its native state or in clear text. Just on to the next one, Nils. Go and secure that information, go and secure those encryption keys on a FIPS validated platform, ideally on a FIPS 140-2L3 HSM, and go and manage the encryption keys according to best practices. Just keep building, Nils. Use compliance policies to control the use of encryption keys. So ensure that, again, that you're taking control of ensuring that the protection of the data on a single database is not down to the DBA, that the protection of the data in a single application is not down to the owner of the application, that you've got enterprise-wide policies and compliance policies that ensure that you are using best practice to go and make sure that you're doing things like rotating keys on a regular basis that adheres to your company policy and removing the risks of humans being too heavily involved. Keep going, Nils. Keep data independent, or keep independent control over cloud keys, something that we're increasingly seeing from monetary authorities around the globe, telling their constituents to go and deploy or use, bring your own key management service or bring your own encryption. Nils will talk a bit more about both of those as we go through this. Use fine-grained access controls for those keys and data, so make sure that only the people that should have access to that data have access to that data via their keys to the kingdom. Go and make sure that you delete keys for secure data erasure, but make sure that you go and do that in a properly managed and auditable process. We call it our quorum control in Fortanix, and use tokenization to reduce the scope of sensitive data. Probably the simplest thing that you can go and do is New York. The simplest thing you can go and do in terms of going deployment is go and use a tokenization tool. It's least invasive way to go and ensure that you're protecting data. On to the next slide, so long as it's not the same one again, Nils. So how can we help you wade through that whole morose challenge bowl of treacle setup? So Fortanix, a software company, a head office in the US, we have a enterprise class confidential compute application called Data Security Manager. That's a SaaS-based application that unifies a variety of different use cases that address what we discussed as issues that OIC have highlighted. So we deploy this either as a SaaS platform. We can deploy this on-prem if required, but we do the application does encryption, key management, secrets management, and tokenization, and obviously enterprise key management at scale, irrespective of where your data lies or resides, whether it's on-prem, whether it's in the cloud, whether it's in Jakarta, whether it's in New York, whether it's in Melbourne, whether it's in Wodonga. Irrelevant to us where that data resides, pretty much irrelevant to us what type of data that is as well, whether it's application data, whether it's database data, whether it's file data, whether it's storage data, whether it's backed up data, etc. All of that's stored on secure FIPS 140-2L3 hardware security modules. From a SaaS platform perspective, all of that hosted in a sovereign environment, PCI DSS SOC 2 ISO 27001 certified in Australia, and the keys to the kingdom always under customers' control. And scalable cross-region, inbuilt high availability and DR, supporting millions, tens of millions of keys in that environment in Australia today. Go, Nils. And as we said, so 15 data centers around the globe, 5 distinct regions, Australia being a specific region. This environment is the largest enterprise key management, SaaS-based enterprise key management solution on the planet today. I think we seem to have our data centers in places that aren't. But anyway, from a Australian perspective, those DCs are in Sydney, Perth, and Melbourne. And again, we would just like to re-emphasise that that data, so that cluster, 5 regions are clusters in their own right. They're not communicating with other regions. We do have a way for you to go and stand up and share information securely and without any clear text ever being in transit, etc. Into different regions if that is a requirement. We have many customers in Australia today who we are managing data for, both in Australia, in Asia, Europe, and in the US. But from an Australian perspective, this information is created, and we only ever hold metadata and encrypted versions of metadata in those DCs in Australia. It is to all intents and purposes, from a Fortanix perspective, subpoena proof. We cannot go and give that information to Joe Biden and his cronies, even if they asked us nicely for it. Just on to the next slide, Niels. In terms of what a data security manager product does, as I said, it's powered by confidential computing, and Niels will talk just a little bit, touch on confidential computing and enclaves and secure enclaves and the importance of enclaves. But a number of, I guess, key areas that we go and address for organisations with our platform. So, key management, again, owning the keys to the kingdom is the single most important thing we believe organizations should do. But we also encrypt data and/or facilitate the encryption of data. So integrating with all the major database vendors and cloud vendors. We have an AI data security module. We tokenize information. We have a secrets management module. We provide a whole bunch of controls that ensure sovereignty of that data, a whole bunch of controls that ensure that you cannot and no one else can go and misappropriate your data unintentionally. And we have a rich RESTful API that connects to modern applications and a whole raft of other ways to go and connect to other applications that you may want to go and manage using Fortanix. We also have an ability to go and extend our platform through plugins, so a really rich extensibility capability using Fortanix to ensure that we can go and address use cases for our customers that may not be addressed out the box in the product, but plugins make it much simpler to go and address newer use cases and/or enable organizations to bring their own applications or bring their own crypto libraries to the Fortanix DSM product. I think I'll hand over to Nils now. I've been talking enough.
All right. Okay. Thanks, Gerry. So let's take a bit more of a look at the enclave-based privacy protection. So Fortanix develops its code using the Rust programming language, and that's widely regarded as the most secure of the modern programming languages. And as Gerry was mentioning, we are a big believer in confidential computing. So we use the latest in confidential computing technology to provide a trusted execution environment, otherwise known as a secure enclave, for the protection of the code and the data. So this ensures that the encryption keys and the other sensitive materials, they could be tokenization templates and so on, It's always encrypted within our systems, whether that's at rest in storage, whether it's in motion, or whether that data is in use. And only properly authenticated and authorized users will have access to use and manage the keys. No one else, including insiders, Fortanix staff, or even a hacker that somehow manages to get root access to the boxes, they're not going to have any ability to access the keys, as they never exist outside the secure enclave in plain text. So that means even in the system memory of the DSM hardware itself, that data is encrypted. And this is something that Fortanix is unique in leveraging confidential computing technologies to deliver HSM level security, but at a web scale. So if we take a look at the enterprise-wide aspect of this, the Fortanix DSM SaaS, it's been designed really from the ground up to support almost an infinitely scalable, multi-tenanted capability built on an expandable cluster of our FIPS certified hardware appliances, which, as I said, they're based on confidential computing technology. So we can protect millions and millions of keys and secrets for thousands of customers, all multi-tenant, all segregated, with the ability to consume these keys and secrets from absolutely anywhere. We also provide complete management of the key lifecycle, and all of this activity is backed by a secure audit log. So user-defined role-based access control and compliance policies that give you control over how your keys are managed. For example, you can define cryptographic policies to allow or disallow certain algorithms and key lengths. So that's very useful if you want to mandate a baseline level of compliance and you want to make sure that you're not using algorithms which are considered deprecated or key lengths that are considered insecure. You can specify quorum approval policies to prevent security critical operations being performed without an M of N quorum of approvers. So if we take a look at the application of the Fortanix DSM to the public cloud, and let's look at the three major cloud providers, there are things that you can do with all three that are significantly going to enhance your security posture. So we can start with bring your own key, which means you have control over the generation of the key material, and then you will securely lease that out to the cloud provider. So you know that the source of your key material is good and secure. You know that the keys are being generated properly using the proper random number generators and so on. And that's very important because if the key is not generated properly, it could be predictable. And that is a way that encryption using such a key could be easily broken. Moving along a bit further along the control and security assurance, we've got bring your own KMS. So with this functionality, you may also have heard this called hold your own key. So that means you're generating and protecting your cryptographic keys, but those keys are not present on the cloud provider's services. So any applications in the cloud that need to utilize that key to, for example, decrypt some data, they need to make a request into your key manager, authenticate themselves properly, and then you will allow them to use that key. But at no time that key will leave your KMS. So this will bring your own KMS, and this is supported presently by Google and also Amazon. And then if you go right all the way to have the most control, bring your own encryption. So applications in the cloud are able to connect directly to the KMS and utilize the KMS directly for the highest level of control, security, auditability. And because we have our Fortanix DSM SaaS service present, as Gerry showed you, in many different points of presence throughout the globe, we're always able to make our service available with the lowest level of latency and the highest level of availability. So let's now take a little bit more detailed look at some of the security mechanisms offered by Google Cloud itself. So the current Google Cloud portfolio, so all data in Google Cloud, for starters, it's encrypted by default, and this is really good. There's nothing wrong with that. But the question is, who controls those encryption keys, as we've been discussing? So we can see with the default level of encryption, it's encrypted, but those keys are not under the customer's control. They're under Google's control. But Google understands this. They understand customers' need to protect and control their own encryption keys. So they've offered a number of services that offer an increasing level of control to customers. So Google has their KMS, where at least customers can come in and choose to generate a key and manage it. Still, of course, that the process is managed by Google. They offer HSM services where Google hosts HSMs, which customers can use. They also offer the ability for the, as we said, the bring your own key type activity, where customer can generate a key and import it to Google. Customers can also, moving all the way along the scale, we have that ability, as we saw on that last slide, where the customer can run their KMS and manage keys completely separate from the control of Google. So let's take a look now at the Google Cloud EKM in a little bit more detail, and also Amazon's XKS, which is a very similar ability for bring your own key that Amazon offers as well. So Google EKM. So what risks can we address and potentially mitigate? And looking at what Google has, what can potentially be done better? So we can see that there is one major thing which we can do better, and it's a recommendation from the Cloud Security Alliance. The keys shall not be stored in the cloud, but maintained by the cloud customer or trusted key provider. So in other words, take control of your encryption keys. Because what are we risking? Well, there's always that potential accidental key disclosure by the CSP. You could have some misconfigured controls. There are potential insider risks. Unfortunately, these things can happen. There's third-party risk, where potentially a party that you've outsourced a job to has outsourced that job again, and your level of control diminishes the further that sort of outsourcing goes. And also supporting various regulations and internal government's policies. So if you add additional levels of control to your key material, then achieving compliance with regulations and putting yourself at lower risk of data breaches or being in breach of the Privacy Act becomes a lot more straightforward, and you can do such things with a lot more assurance. So let's take a bit of a overview look at Google EKM. So Fortanix, so we were the launch partner for Google Cloud EKM, and that was back in 2019. So it's been around a while now. So any data encryption keys, otherwise known as DEX, used by Google services, a couple of services here, for example. So we've got BigQuery and Compute Engine, but of course there are many more services which can use these things as well. So they're encrypted first under a key encryption key, otherwise known as a KEK, and that gets stored within Google KMS. So that's their KMS service. But that key then gets encrypted with a master KEK, and that master KEK gets held externally within Fortanix DSM. So that KEK gets generated and protected within the Fortanix DSM. So you know the provenance of that key. So if any data has to be decrypted within GCP with one of these keys that's so protected, Google's actually going to securely send the encrypted KEK to the Fortanix DSM, and then that will be decrypted with the master key. So therefore, if you disable access to that master KEK, then Google's got no way of decrypting your data. And that's the control aspect. And what's more, if you're using Fortanix DSM for this sort of process, you get to audit every single key operation that Google calls. And that's great for having a record of what has happened, for compliance purposes. So without using something such as EKM, Google has access to your encryption keys and can decrypt your data. But if you're using Google Cloud EKM with Fortanix DSM, you've got sole control over your encryption keys to meet the highest security and compliance standards. So, I mean, if you want to take a look at, you've got as is, and then you got with Fortanix, it's pretty straightforward to see that if you're protecting your keys, you don't have to trust the external party to manage those keys. You've got that higher assurance. So, as should be quite clear by now, the benefits of utilizing and controlling your key management, the key provenance, the key was generated securely, where that key is located as well, of any copies that have been made of that key, so you don't have the question of the closing the stable door after the horse is bolted, so to say, and you've got independent audit logs, which is something that we take very seriously. We keep them tamper-proof, we sign them, so they can be a single source of truth. Access control, so the keys are always outside Google, or the cloud provider. I mean, this example is Google, but it can be applied to anyone really. So access to data at rest services requires its external key, and as is mentioned, there's a kill switch. So if something something really has gone wrong, you have that way of simply turning off the tap, and that's going to ensure that you turn off the tap. Nothing more can actually happen, and there's going to be no more access. The other nice thing is you've got centralized key management. So of course it's not just Google that you're going to be using with your key management service. You're going to have potentially Amazon. You might have other services such as Salesforce, ServiceNow. You might have database encryption, Oracle database, Microsoft SQL database. You might be doing data tokenization. I mean, there's a whole plethora of things that you could be doing. But ultimately, with encryption keys, you want to have one centralized management portal for everything, for all your applications, for all your keys, a single source of truth, auditing, and so on. And that's something that can really be quite powerful, and can allow your security officers to really sleep easy at night. So it sort of goes without saying that this is going to enhance the security of your data. So data security capabilities add-on, as I mentioned, tokenization, multi-cloud, so on and so forth, but also confidential computing as well. So Gerry mentioned we got the ability to do plugins. So that's additional applications that you can write, you can run on the DSM, and they'll be protected within essentially a HSM security boundary. So really the technology, the sky's the limit with what you can do. And of course, compliance. So any guide to using crypto is going to recommend that you use FIPS approved algorithms and FIPS approved key management and storage and so on. So that's something easy to achieve with Fortanix. We have a FIPS validated HSM that we use. but yeah, it is unique that it is web scaled. It is infinitely scalable. And as I've mentioned, we have that audit log functionality as well. So let's take a little bit more a look now at the AWS equivalent to Google EKM. So AWS launched their XKS capability last week. Well, actually, it was not last week. It was sorry, slip of the tongue. It was last year, last year. And Fortanix, we were a launch partner, and this provides a very similar capability to Google Cloud EKM. So we've got the customer root key, they call it, and the root key is used to envelope other keys protected within AWS KMS. So any use that AWS wants to make use of the key, they're going to have to authenticate and connect to the Fortanix DSM. So again, you've got that whole ability to essentially turn off the tap. If something has gone wrong, something's not right, disable access, then that key is no longer going to be used. And of course, any access that Amazon is making to the key, that's going to be logged in your audit logs as well. So again, for compliance purposes, it's very easy to see and have a historical record of what's been happening. So why would you want to go with Fortanix? So as a bit of a summary, we provide a modern cloud-native SaaS solution, developer-friendly REST APIs, deployed on premises or in the cloud, whatever you prefer. We offer a wide range of data security services with a simple, flexible pricing model. DSM, as we've mentioned, is certified up to FIPS 140-2 level 3, and built web scale enhanced by the latest confidential computing technology. So we integrate with a growing ecosystem of third-party applications. Our certified integrations with third-party apps is probably greater than 140, and that number is constantly rising. It's something that we take very seriously and working on constantly. But ultimately, the DSM is designed to be something easy to use and allows you to consolidate the number of tools and vendors that you use. You can greatly reduce your complexity. So with that, I'd like to show you a very quick demo. So I'm going to show you Google External Key Manager, and we're just going to have a look at how you can protect some data in Google Storage Bucket, and then show you how to access that data. And then we'll show you what happens if you turn the so-called kill switch off. So let's go across to that now. So what you can see on the screen here is a Google Storage Bucket that I have. And if you take a look on the screen here, you can see the encryption type is a customer managed key. So this tells us that it's an externally managed key. If I go across to my Fortanix DSM user interface, we can see here, this is the information on the actual key that I'm allowing Google to use. And so, you can also see down here, we've got activity logs for the key and so on. So that will tell us every time there's some sort of access to the key, it's going to be there in the audit log. So let's just take note of the time. So in Australia, it is 11:16 a.m. So I'm now going to go across to my bucket, and I'm going to access the treasure, the secret document in my bucket. So we'll go ahead and download that. And okay, I got access to the secret document. There's obviously valuable data in there and so on. So if I go across to the Fortanix DSM, and then I just refresh my activity log. And okay, it's a little bit hard to see there, but it says 11:16 a.m. Google service account used GCP key to perform decryption operation. So we can see that there was a unwrap operation happened to unwrap, so the top key of the hierarchy that eventually unwraps that encryption key that encrypted that particular storage bucket. Okay, so that's fine. So let's close that file now. So now let's say we don't want anyone to be able to access that storage bucket anymore. So essentially we want to cut off access. So what I'm going to do is I'm going to disable that key on the DSM. So now we'll go back to our storage bucket again, and we'll attempt to download that file again. So because this is stored at rest encrypted format, every time we try to download it, it's going to be decrypted on the fly. So let's try and download that again. And you see now we get an error message coming back saying unable to decrypt with Cloud KMS. So that is because it could not reach the DSM and it could not decrypt the key because we have deactivated access to that key. So of course, this Google KMS, storage bucket encryption is just one application. There are many others. BigQuery database is another application here. Again, the possibilities are endless, but I just wanted to show you that very quick demonstration, just to show you that extra control that you get by utilizing external key manager. So, Gerry, I'll hand back over to you for the closing.
Thank you. Just want to move on to the next slide. Just to wrap up, as we've said a couple of times or several times throughout the course of this session, we do have a sovereign cloud instance in Australia, so across 3 data centres. Those are Equinix data centres. We use Equinix as a DC provider globally. We recently launched something we call DSM Explorer, which is a freemium offer for anyone who wants to go and sign up to that freemium offer. Can you just move on to the next slide, Nils? So it gives you an ability to go and, so tokenization, for example, the simplest way that you can go and protect your PII information is to go and tokenize it. You can sign up at Fortanix.com for this Explorer tier, which is free forever. So you can go and today you can go and protect the application database that you're most concerned about from a PII information perspective, and or if you want to go and look at the capability that something like AKM for Google or XKS for AWS can bring you you can do that as well. You can also go and sign up for or bring your own key instance for Azure. So you can start to experience how simple it is to go and take control back of your own environment, of your own destiny, and or how simple it is to start protecting the PII information of your staff, your customers, and or our citizens, depending on which type of organisation you work for. So on that note, I'd just like to thank you all for your time. I think we scheduled this for an hour, so I might give you 9 minutes back left in your morning to go on with some work. Thanks for your time and attention today. We'd love to get feedback from you on the session. As I said at the outset, we will send you both the deck, we'll send you more information on the freemium version of Fortanix. All of our documentation sets are publicly available on our website at support.fortanix.com. Should you want to find any more detailed information across anything that we do, whether that's tokenization, encryption, the management of keys, etc. And look forward to hopefully speaking to you in the future, and welcome you to the Fortanix family. Thank you very much.